happens to Arctic lakes as they warm? What happens to the methane contained therein? Now, as you would probably elucidate, warming Arctic lakes may release more methane than expected. Okay, what's going on? And Science TP. Yeah, this is called field work. Don't exactly have a luxury accommodations, shall we say. The findings are important because methane is more than 25 times more powerful than CO2 as a greenhouse gas. Arctic lakes are already major natural methane sources globally, as well as the permafrost. But the processes that control how methane is produced and released from lake sediments have remained poorly understood until now. There's been some prior work done, looking at lakes, freshwater lake. We know of the work done from methane being released from, say, the East Siberian Shelf, right, in the Arctic Ocean. I've documented and discussed that with you many times, but now we're looking at more focus on what's going on with Arctic lakes themselves and what's happening with the sediments and methane. So, PhD candidate Marie Bulanova from the Geosciences Department at UIT, the Arctic University of Norway, that was involved with an international team. They looked at 10 Arctic lakes across Svalbard and subarctic Scandinavia. They found that methane production in lake sediments was highest where lakes had greater productivity. In other words, more algae, aquatic plants, and land vegetation. And shallower depths. That's going to be important. These findings are published in the Journal of Geophysical Research, Biogeosciences. We were surprised by how clearly the productivity of the ecosystem was linked to methane production, said Marie. Our results show that warmer and wetter conditions increase biological productivity in Arctic lakes, which in turn drives methane emissions from their sediments. This is an excellent summation. Our results show that warmer and wetter conditions increase biological productivity. Right there. We know that the Arctic is warming 4 to 5 times faster than the rest of the planet. And we also know that precipitation rates are increasing in the Arctic. Right? Warmer air can hold more moisture, for example. So you combine those, you get increase the productivity in Arctic lake, but it can also increase methane coming out of the sediments. Most methane was produced within the top 10 centimeters of lake sediment. That's about 4 inches. In these shallow layers, the combination of fresh organic rich material and enhanced microbial activity creates ideal conditions for methane generation. The researchers calculated how much methane is likely to diffuse from the sediment into the overlying water and then eventually into the atmosphere. And here are some researchers getting ready for lake sediment coring at Lake Aspevatnet in Lyngen, Norway. Nice typical Arctic scenery. And you got a little inflatable vessel there. So, what are some of the differences between Arctic lakes and elsewhere? The team compared their findings with data with over 60 lakes worldwide. This revealed that methane fluxes from individual Arctic lakes are generally lower than those in tropical or temperate regions, but still significant and highly variable considering the large number of lakes in northern landscapes. And surprisingly, they are similar to some boreal lakes. Okay, so let's kind of tease that paragraph apart a little bit. Tropical and temperate regions. Mangrove swamps, mangrove forests. A lot of methane gets released in those locations. In fact, I remember when I spent time in the Caribbean working through mangrove regions, that if the sediments were disturbed, you can definitely detect a few odors of some gases, let's just put it that way. So Marie explained one of the striking aspects of this work is how different Arctic lakes are from each other. Some release much more methane than others, depending on local factors like vegetation cover, lake shape, sediment composition. I'm guessing that's going to be the big one. That's why it's essential to study a wide range of lake types if we want to understand the Arctic's role in future climate setbacks. Okay. And this is harkens back to, the statement about some boreal lakes. What are the boreal lakes doing? Well, it depends on the sediment composition, vegetation, and so forth. The researchers also built predictive models using machine learning to identify the most important factors driving methane emission across different biomes. This helped to highlight the importance of primary productivity in climate variables, especially temperature and precipitation. And more researchers at work. And I like the headline, Professor Anders Schomacher keeps watch for polar bears. Seriously, that's a concern. I know that when I was up in the Arctic myself, off of Point Utqiagvik, we would hire someone whose sole purpose was to keep an eye out for polar bears. Because polar bears hunt humans. We're on their menu. So this research adds an important piece to the puzzle of how Arctic ecosystems respond to climate change as temperature rise and growing seasons lengthen. Arctic landscapes are greening and lakes expect to become more productive, which could lead to higher methane emissions. The study underscores the importance of including lake sediments in Arctic greenhouse gas budgets. Yes. It also shows that seemingly small environmental changes can have large effects on methane emissions. Arctic is rapidly changing, and we need to understand all the feedback involved. Our work suggests that increases in ecosystem productivity, something we could think of being positive, can also increase methane release and further accelerate warming. Well, there's an up yours. But the point is well taken. The Arctic is warming, precipitation is increasing. This can favor autotrophic productivity. But then there's a downside to that, and that more methane gets released into the atmosphere, further adding to the warming. Basically a positive feedback loop. So important research. I hope they continue with this and continue on into the foreseeable future. Something else to keep an eye on. Thank you for your time.